Okay, so the first thing that I will try to fit will be the familiar model that we have here. It is this thing, Yij equal to mu plus alpha I plus epsilon ij. Now the mu will introduce an intercept column, that is the columns of all ones, and that is the default behavior of R. So all that I have to do here is to write this fit 1 equal to ln il tilde variety, and the data set comes from agree. That should work. So let me try that. I will try this, and it has produced some fit. Well, let's take a look at that fit. And we get the first surprise. The first surprise is that we do see the intercept term. Unfortunately, we do not see variety 1 value. So I see mu hat 212.067, I can see alpha 2 hat, I can see alpha 3 hat, but what happened to alpha 1 hat? Well, what R always does, and all other softwares also do the same thing, is that if it constructs the model matrix, the design matrix, it will never construct a model matrix which is not full column rank, that is, for which the columns are not linearly independent. If it finds that there is some linear dependence, it will throw away one of the columns, and that is precisely what has happened here. So let's try to understand this by looking at the model matrix that R has constructed for us. Model.matrix of fit 1. So the command is model.matrix of fit 1, and you can see that there is a term for intercept mu, one column for alpha 2, one column for alpha 3, and the remaining column has been just thrown away, which is natural because intercept is all 1, 1, 1. Variety 1 will have 1 on only those places where what variety has been shown, and variety 2 and variety 3 similarly. So if I add all the variety 1, variety 2 and variety 3 columns, I will get the same thing as the intercept column. So it has dropped one of them. Now how did it choose which one to drop? It could have dropped the intercept, it could have dropped variety 2. Well, R has this habit that it will take the bunches. The first bunch consists of the intercept term. The next bunch consists of the variety. In each bunch, if there is any problem, it will drop the first few columns. So what it effectively fits is this model. Alpha 1 is equal to 0. Mu plus alpha I plus epsilon ij, where alpha 1 is equal to 0. So the estimate for alpha 1 has been forced to be equal to 0, and that makes the least square estimators unique. Now, there are other softwares that will behave in a different way. For example, I guess SPSS will drop the very last one, so variety 3 will get dropped. I guess SAS has an option by which you can say which one you want to be dropped and things like that. But this is the behavior of R. Now suppose I want to fit the same model but in a slightly different incarnation, the one that I showed in my video, the very first thing that I showed, namely this one. So this is just Yij equal to alpha I plus epsilon ij, where I do not have the intercept term. So that will be this thing. Fit 2 equal to lm il tilde variety minus 1 will guarantee that the intercept term is not there. This is an equivalent model. So I will make this precise what is meant by equivalent. So let's try that. And if I now take a look at what I get from fit 2, I now get alpha 1 hat, alpha 2 hat, alpha 3 hat. So it is always going to give me 3 estimates because the rank is 3. Now let's see what is the model matrix or design matrix for fit 2. Here you will see there is no 1, 1, 1. It is just as you will expect. In plot 1 and in plot 7 and in plot 8 you had variety 1, so you have 1s there. Variety 2 are in plot 2 and plot 3 and plot 6, and the remaining 2 has got variety 3. So you are getting this. This is a full column rank matrix. All the columns are linearly independent.